Welcome back to our video on nonlinear rules. In our last video, we talked about a special nonlinear rule or relationship known as a quadratic rule. We talked about how the quadratic rule always has x squared in it. And the simplest quadratic rule is this one here that we looked at in the last video. Y is equal to x squared. Of course, quadratic rules are not always this simple. There are many quadratic rules, and many of them don't just have x squared in them. Sometimes we add or subtract certain amounts from x squared. Sometimes we multiply x squared by something. But quadratic rules can become much more complex than the one that we see here. On the right-hand side of the page, I have another algebra table with a nonlinear rule. And this nonlinear rule is also quadratic. I know it's quadratic because when I examine what our y values are increasing by, I find that even though y is increasing by a different amount each time, the amount that they are increasing by is in a pattern. Let's have a look. The difference between 4 and 7 is 3, so we're adding 3 this time. The difference between 7 and 12 is 5, so we're adding 5. Here we're adding 7. Here we're adding 9. So you can see that y is increasing by a different amount each time, but again, we can see the same sort of pattern as we saw earlier. We go up by 3 and then we go up by 5. So there's a difference of 2 there. Then we go up by 7, another difference of 2. Then we go up by 9, another difference of 2. So again, we can see that this must be a linear rule. We're seeing, a quadratic rule. We're seeing the same sort of pattern in the way in which y is increasing. So let's go back and see what our quadratic rule is here. We know that the basic quadratic rule is y is equal to x squared. Now, 1 squared is equal to 1. But we have 4 over here. What would I add to get from 1 to 4? I would add 3. 2 squared is equal to 4. But I have 7 here. What do I add to 4 to get 7? I add 3. This might be our pattern. Let's see if it happens with the rest of the values. 3 squared is 9. 9 plus 3 gives me 12. 4 squared is 16. 16 plus 3 gives me 19. 5 squared is 25 plus 3 gives me 28. So we're not just squaring x here, we're also adding 3, and our entire quadratic rule will be x squared plus 3. This is a slightly more complex rule to the one that we saw earlier, but nevertheless it is still a quadratic rule because it includes that very important value in our rule, x squared. Now let's look at this final algebra table. We can see it's a nonlinear rule because, as before, y is increasing by a different amount each time. So from 0 to 2, we add 2. From 2 to 6, we add 4. From 6 to 12, we add 6. From 12 to 20, we add 8. So once again, we can see that pattern in the differences. the amount that y is increasing by is going up by 2 every time again. So again, we have a quadratic rule now, and we know that the start of our rule will be y is equal to x squared. Now, let's test that on all our values of x and see if we need to add or subtract something to complete our rule. Okay, 1 squared is 1. But we have 0 over here. What do I add or subtract to go from 1 to 0? I need to subtract 1. 1 minus 1 will give me 0. Now, 2 squared is equal to 4. Okay, what do I need to subtract from 4 to get back to 2? I have 2 here now. I need to subtract 2. Now, 3 squared is equal to 9. But I've got 6 over here. What do I subtract from 9 to give me 6? I subtract 3. 4 squared is equal to 16. But I have 12 here. What do I subtract from 16 to give me 12? I'm going to subtract 4. 5 squared is 25. But I've got 20 here. What am I going to subtract from 25 to give me 20? I'm going to subtract 5. Okay, so this is a bit different to the previous one we just did. We're not subtracting the same amount each time. However, is there a pattern in what we are subtracting? If we look closely at all of our subtraction numbers here, 1, 2, 3, 4, and 5, we see that they are exactly the same as our x values over here. Each time we are subtracting our given x value for that number. So my rule this time isn't going to be -1 or -2 or -3. What I'm going to minus here is my value of x. So the rest of my rule is x squared minus x. So what we add and subtract to x squared isn't always just a number. Sometimes it can be x, or it might be 2x, or it might be 3x. It just depends. We'll come across some more complex quadratic rules later. Thank you.